Okay, can everybody hear me? Okay,
Yes.
good. Okay, and all right, and I assume everybody can see this pad of paper here, I hope. And next, so does anybody have any questions before we, on superposition first? Anything on superposition? Y'all hear me okay?
Yes, sir. No questions.
No questions at all? Anybody?
Wait, you mean super nodes or?
I mean, sorry. No, I meant Thevenin. I'm sorry. I've been getting all these questions about superposition. We haven't covered it. I'm sorry. Now back to reality. Yeah, on Thevenin's theorem. At all? Anything at all?
Could you go over how to find I naught using Thevenin's? I know we did it with V naught several times.
Well, I naught is for Norton's actually, isn't it? And since you brought that up, let me show you a conversion trick, if you're okay with it. Everybody, I'm going to show you this. This is a relationship between voltage sources and current sources where you can do a neat little trick. And I'll show you how this is applied. All right? Everybody got this? I know you're a little nervous about the quiz. If you're ready, you're going to be fine. Everybody okay with this? All right. Now, if we have a voltage source, just call it V source here, and a resistance, pen's about dead, RS, call it R, right here. And this is plus to minus some voltage that you're going to put there, right? You can put anything across there. What does this look like to you? Anyone? It should resemble something that we found we could take any circuit and turn it into. Anybody?
Thevenin equivalent.
Exactly. It looks like a Thevenin equivalent circuit to any circuit that's linear, correct, class?
Mm-hmm.
Now, if you have this, this is also exactly equivalent to a current source, which I'm going to call IS, and a resistance, this resistance R here, and these two will be the terminals, plus to minus. Now, across these two terminals, and I hope you can all see that, these two terminals will give you the same voltage current for any given load. But here's the kicker. This value of IS is equal to VS over R. Do y'all follow me now? Now, just listen to me. I'm going to do an example of this. I'm going to prove it, okay? I'm saying that these two are identical, and we can use this. This is called a source transform in the book. And I think, I'm not sure about the book you have, but this is the terminology that's commonly used as source transform. And it's extremely useful, and I'll show you how in a second. First, let me prove that this is the case. I don't know where that's coming from, but if I find it, I'm going to mute it. I don't know if it's there. If you can find it, tell me, and I'll mute whoever it was.
I think there's a mute all option.
I don't need to mute everyone, just people that are with unnecessary sounds in the background. It's going to happen. I'm just trying to get rid of it. All right, you ready on this one? First, I'm going to prove this to you in a most general sense. Suppose I go ahead and I have a circuit here with a VS, or I'll call it V naught, all right? And I'm going to just call this resistance R. And then I'm going to put an R load on it, right? Now, I can say that the current through here, I, would be just V naught over R plus RL. Do y'all agree with that? Class?
Yes.
You're out of focus.
Oh, I even downloaded some software for this, apparently. There we go. Y'all agree with that right there? That's the current, right?
Yeah.
Now let's do the source transform. So I'm going to take that voltage and divide it by R and put it and make it the current source. So now I have a current source here. That's the symbol for a current source. That is simply V naught, right? Over R, right? Y'all with that? All with me on that?
Yeah.
And then I'm going to put that resistance in parallel, right? With me? It went from there to there, correct?
Why put it in parallel?
You see the transform right here?
Mm-hmm.
It goes in parallel. You see how it's in parallel?
Yeah.
Okay. Now watch. Now I'm going to put the load on RL. All right, and we want this current. You all follow me in that, class? Thumbs up, some way of indicating at least you understand. You got it. You okay with that? It helps me immensely. You got me?
Yes.
All right, now what's that current going to be? Well, it's the actual current going into both of those. Do you all agree? If you know the current into a pair of resistors, you know the current through either resistor. Do you all agree that these are in parallel, right, class?
Mm-hmm.
Everybody? All right.
Yes.
What's that current going to be? It's going to be the source current, or it's V naught over R, right? Times what? The opposite resistance, R, right? Divided by the sum of the two, R plus RL. Do you all agree with that?
Yeah.
Opposite resistance divided by the sum times the current into. Now, what do you see happening? The R's here cancel, right? Y'all see that, class? I don't mean to bore you. And
Yeah.
but I
Just
gotta make,
to
huh?
just to clarify, that was R over R plus RL, or
Right.
R
I mean,
times.
no, it's R over R plus RL. But what is current division? You take the current into the parallel combinations, right? and we multiply by the opposite resistance we want the current through, and then divide it by the sum of the two resistances in parallel. Correct, class? Right? I'm sorry, it's so dark in here. Anyway, are you with me on that?
Yep.
Let's see how this right there is identical to that, right? It's V naught over R plus RL. Do y'all get me on that?
Good.
This is a source transform. You're going to see how this can make your life super easy, and I'm going to do an example. I wanted to cover this. I'm glad this led right into this by the question that was asked. So now if you take a look, and this will help you immensely on problems because you can quickly do them. So if you look at, say, you can pick any problem you want. Let's go 272 for the heck of it. And you can do 272 any way you want. And I got a statement. This is problem 272. I'll show it to you. This is out of the old Irwin book. We'll be using a whole bunch of different books by the end of this course. I've got a bunch of them piled up there. So this is the old problem, right? You got 12 and 3K, 2 milliamps, 3K, 2K, 3K, and minus 24 volts. Can you all see that right there? I hope you can. Right?
Yeah.
All right, so I'm going to redraw this, and I'm going to show you how quick you can do this. So you had a 12-volt source. All right, then you had the 3K.
Can you move the paper down?
Yeah, thank you. Make me aware when things are not right. 3K, and then 2 milliamp. Then 3K. And then 2K.
Out of focus.
2K. And then 3K. And then minus 24. Make sure you take note that minus 24 is at the top, right? The minus sign's at the top is what I'm getting at. Everybody good with that? Now they actually want the current through here, right? You agree with that, class? Thumbs up? Right?
Yeah.
Yes.
If they want the current through there, if that was a Thevenin problem, you would remove that first after identifying it. Do you agree with that?
Yes.
All right. In this case, if we're going to use source transforms, you do not transform this. Just put a little circle around it. So it tells you in the world you're not going to transform that. All right. But here's what we're going to do. We're going to create a Thevenin equivalent current a Thevenin equivalent voltage source or a current transform of that, which is called a Norton equivalent, without ever doing the usual way we did it, where we'd actually go ahead and we take the open circuit and then we turn off the sources to find R Thevenin. Do you all remember how we did that with R Thevenin, right?
Yeah.
We're not going to do that. Here's what we're going to do. We're going to do source transforms. Now take a look at this. You see I have a voltage source in series with the resistance, correct?
Right.
I want to make sure everybody sees this, correct? This is very valuable. You could even use it on the quiz today. Are you okay with that?
Yep.
I'm going to transform that into a current source in parallel with 3K. Y'all see this?
Okay.
All right, so that would be what? The current source would be 12 over 3K or 4 milliamps, right? You agree with that?
Mm-hmm.
4 milliamps, it would be in parallel with 3K. And here's the beautiful thing you're going to see here. We can add the next current source. Now you see the next thing in line there is a current source that's 2 milliamp. You all see that? That's this source. I just brought it down here. I'm not redrawing the rest of that circuit. Do you all agree with that?
Yeah.
I'm going to stop for a second, make sure everybody takes a good hard look. By the way, how many people do we have participating? I'm not able to see that.
94.
Excellent, excellent. Just about a full house. Now, I want you to take a look at, you see how these two current sources are in parallel?
Mm-hmm.
Mm-hmm.
You can effectively add them up. They're both in the same direction. They're both going into this node. add them up and replace them by a single current source. Do you all see that, class?
Yeah, so 6.
6 milliamps. How many see that though? I want to make sure you see it. They're both in parallel. They're going into the same terminal right here. It's 2 milliamps there, 4 milliamps there. It's like just one single 6 milliamp source. So that's what I'm going to do. I'm going to say that's equivalent to just one 6 milliamp source in parallel with 3K. Y'all see that? Now these were where the terminals were. You with me? So now what we've done is we've accounted for these 3 elements. Do you see that?
Yes.
Want everybody to take a good look. I can't, most of you don't have your cameras on. I don't know if I'm able to see most of you, but I'm gonna just take a peek. Okay, the only people with cameras on, I guess, are on that first page. But you're gonna have to turn your cameras on for the quiz. It has to be on, and you have to be visible at all times. And you can't use your phones for anything but taking pictures of the quiz. But I just wanted to make sure everybody can see this. Are you good with that, class?
So are you able to combine those because they're going in the same direction?
Right, and if you listen carefully what I said they're going into the same node. Effectively, that means they're in parallel, right? The node in the bottom and the node in the top are directly across both of these current sources. Do you see that? Whoever asked the question?
Yeah.
Okay, everybody with me on this one. Now, take a look at that. I've reduced the number. I've had 3 elements. I reduced it by 1. Now, do you see these 2 are in parallel? Class? Can't we replace those by a voltage source with a series resistance, class? Remember what remember what source transform said. A voltage source in series with the resistor is the same thing as a current source in parallel with the resistor. Wasn't that the premise? How many remember that?
Yeah.
Thumbs up or some way of indicating an affirmative, right? Yeah, and this is exactly why we're using it. So when we do that, now I take this and I make it this. The voltage source, what would the voltage source be, class?
The
12 volts.
18 volts.
Right,
18.
18,
Oh,
it's
18
3
volt,
times 6, so it's 18 volts, right? And it would be in series with 3K, right?
Yeah.
Y'all agree with that?
yeah.
Yes.
Thumbs up. I hear yes. Okay, everybody? All right, the next step is what? Now I'm at this point in the circuit, right? I've accounted for these 3, right? You see how the next element would be 3K right here. Y'all see that? Thumbs
Yeah.
up. I want to make sure everybody sees it. All right. Now, can't I just add these 2 and make them 1 6K? How many agree with that? Agreed? Okay, so that's what I'm going to do. So now I'm going to take these 2 and make them 1 6K. And I'm sorry, this is a little, on a board it's easy, but not here. So now I'm going to make it 18 volts. And it's just going to have 6K here, right? I neglect the ohms, but K to me tells it all. All right, now I started with that. Now I've included this resistance, right? Everybody?
Yeah.
Now what I'm going to do is this, just listen. I'm going to take this and I'm going to put it in parallel. Here's why I'm going to put it in parallel. I'm not going to touch this one where I want the I naught. Y'all see that? That I don't do a thing with. That just stays until I'm my final step and I analyze it. You okay with that? But look, I'm going to take this and make it a current source in parallel with that resistance. And I'm going to take this one and make it a current source in parallel with that resistance as well. Do y'all see what I'm up to? Because y'all see it's a series resistance and a voltage source, right? Right here, I've taken this whole mess and turned it into a series resistance and a voltage source. Now I'm going to turn the whole thing into just, I'm going to take the one on the left and make it a current source in parallel with the resistance. So this becomes what? How much, what's the current source to that, class?
3 milliamps.
Right, going up to, I'm not saying that, but it's going up. So it's 3 milliamps, right? It's 6 into 18 or 3 milliamps, right? 6K into 18. And it's in parallel with 6K, correct? You all see this? And on purpose, I'm just going to cut out, because I don't want to have you confused, but I'm going to cut out the actual resistance there, 2K, where we want I naught across. I'll just leave that out, okay? So you won't get confused. Are you okay with that, class? Just remove
Yeah.
it for now. Now, go ahead and what happens to this second one over here? Take a good look. I've got 24, that's 24 volts and 3K, but notice the terminals. Plus is grounded, or should be grounded. The negative terminal is on top. Do you all see that? With me on this? I want you to be very aware of that. Now, what does that mean? That means there will be a current, which would be 24 over 3, right? Or 8 milliamps, 8K, correct? But it will be going down. Do you all follow me? Net up. How many see
Yeah.
that? Okay? You good with that?
Yes.
This will help you, trust me. So now I come over here and I say, well, I got a current source, but it's going the wrong way in a sense. It's going down, not up, and it would be 8 milliamps, right? And I have a resistance of 3K still, right? Take a good look at this, and I'll move it up for you. That's supposed to be 8 milliamps. Do you all follow me on this? I want you to be sure you take a good look at this. Okay? All right. What am I going to do next? Any guesses? There's bright people in here. I know you guys know. Do you see these two are in parallel, class? The 3K and the 6K?
Yeah.
How many do? Okay, if you see they're in parallel, what am I going to do?
Combine them.
Sign resistance.
Yeah, and replace them by 1. So 6 and 3 in parallel is 1 over 6 and 1 over 3, right? And that's what? 3 over 6 or 2K, isn't it, class?
Yes,
So
sir.
these two become 2K resistance. So I'm just going to draw it down here. All right. And then I have what? 3 going up, 8 going down. So effectively, how much do I have going up to the upper rail right here, class? Think about it. 3 going up, 8 going down, or minus 8, it's what? Minus 5, isn't it, class? How many see that? Minus 5.
Yep.
Give me 1 second. Hey, Tom, I'm teaching now. I'll call you back when I'm done, okay? Bye-bye. All right. Okay, so I got 2K there, and I have minus, you can do it this way. I just put 5 milliamps going down, right? Y'all see that, right? And now what can I do? Now that resistor 2K I took off, I'm going to put here. Y'all follow me? How many do? I mean, this is perfectly legitimate what I'm doing. And it's easy. That way we don't have any matrix math, right? We just eliminate all the matrix math by simple transforms. Now I come down here and I got a question.
Did you go over how you did that again?
Sure. You see I have 6K and 3K in parallel.
Mm-hmm.
So that reduces to 2K. Are you okay with that?
Okay, yeah.
All right, now you see I have 3 milliamps going up to here and 8 milliamps coming out, right?
Mm-hmm.
Isn't that the same thing as just 5 milliamps down? 8 minus 3 would be 5, right? And it's going down?
Yes.
Okay, that's why.
Okay, thank you.
Sure. And then now I'm going to ask this. What's the current going this way without much thought? Anyone?
2.5 milliamps.
And it would be negative, wouldn't it? Isn't actually the current going like this and like this, right? So if I wanted the current in this direction, it would be minus 2.5 milliamps. It would be half of a 5 milliamps, only with a negative sign. How many see that? Class, you guys got it? Okay, I mean, do y'all see it? Some people are writing. If you're writing, you're writing. I have a question for just one person here. Justin Harbert, can you hear me? could you unmute your mic just for 1 second?
Yes, sir. What's up?
I see 2 people in your room.
Yes, sir. He's my roommate. He's also in the class. He's having some bandwidth issues. So he's
Uh-huh.
been watching in here.
Oh,
He
this
should
is,
be good to go back to his computer when the quiz starts.
okay, for what it's worth, you're not allowed to work together, and I'm not gonna punish anybody. I'm just trying to do my job. You're gonna have a monitor here.
Yeah.
I don't know how many monitors. I know this class right now has eyes on them from everywhere. And the only thing I can tell you is I'm being watched, you're being watched, we're all being probably watched and listened to and recorded. So be on your best behavior is what I'm saying. That's
Yes.
the only thing. I'm gonna leave it at that. Do you all see what I'm talking about right here? Just a thumbs up and some affirmative action, okay? I gotta know you know that I see it. And I'm not
So-
trying to bore you. Hmm?
You saying it's a positive 2.5 amps going down? Or
No, I said it's what? Negative 2.5 milliamps. The actual current going down is negative, right? The real current would go up. Do you agree with that?
yeah,
All right, matter of fact, you could take 2K and 2K in parallel. That's 1K, isn't it?
yeah,
And wouldn't all the 5 milliamps be going this way with the 1K?
yeah,
And so half of it would be going between the 2Ks, right? But it would be
Yeah.
going from bottom to top. And if I wanted the current as shown here, it would be a minus 2.5 milliamps. Do you agree with that, Joseph?
okay. But I'm confused about why you have the arrow pointed down if you're describing the value of the current
See
as
this?
it goes.
No, I'm saying this is what I'm after, right? That's what I want, right? I want this. It's minus 2.5 milliamps, correct?
Yeah,
But I said, when I look at this, just intuitively, this current is going this way and this way, right? It's going up, swirling that way. But if I wanted it measured in this direction, it would be minus 2.5.
okay. That
This
does
one-
make sense.
That's the only point I'm making. Are you good with this, class?
Yeah.
All right. Next. Now, this is a great thing. It's a good tool to use if you're asked to do Thevenin, right? You can check your work this way. But this is a Thevenin equivalent circuit right here. If you take this, R Thevenin, now remember, you get that out of there, R Thevenin would be 2K, right? Y'all see that? Actually, I would convert it to a voltage source. I would take this current source in parallel with resistance and turn it into a voltage source of what? This would be your open circuit voltage, 10 volts, right? 5 times 2K, 5 milliamps 2K would be 10 volts. And then it would be in series with 2K. And that would be your Thevenin equivalent circuit, right? That would be your open circuit voltage. This would be R Thevenin. And then you would put your load in there. Y'all follow me? How many do? It's very straightforward, very simple. But the source transform is the thing that makes it so easy to do. It does, it really does. I know there's analogs of this in ME and aerospace engineering. I'm not exactly sure I'm the one that wants to teach it, but the person who called me on that phone is Dr. Thomas Birch, and he'd be happy to talk to you about this if you want, because he's an expert in a lot of this stuff. Some of you are having Dr. Birch now, it's my understanding. Are we good on this class? Now, before, that's one of the things I wanted to go over today. The only other thing I'm going to do before we move out of this chapter is going to go through loop or mesh currents, but I don't have to do it today. And then we'll be into chapter 3 for sure next lecture. And that's time varying stuff, transients as well as steady state AC. But I wanted to ask you one last thing before the quiz is given. Does anybody have any burning questions about Thevenin right now? First Thevenin. Any burning questions about Thevenin? And what I just showed you, you can use in the quiz today. It's easy to use that too. Anybody? Anybody at all? Thank God. Jessica, I figured I'd hear one from you, but I'm glad I'm not. All right, now anybody have any burning questions about nodal? I'm astounded. I'm just shocked.
Go over it a little bit.
What? Couldn't hear you. Please say that again.
Can we just go over it a little bit?
Can you give me a problem you want? I mean, I gave you a lot of problems.
I don't have it in front of me right now.
Huh? I'm sorry, I could not understand you. Could you say that again, please?
I don't have any in front of me right now.
All right, does anybody have a question about nodal that is related to a specific problem? All right, since you asked, how about we just take a peek at something? This one says superposition. Never worry about the way the book says to do it. If I tell you to do it with nodal, just look at the answer. The answers will compare. So if I was to do this one with nodal, what would I do, class? You might as well tell me.
You'd make a super node.
Well, would I? Why? Isn't this grounded? Right? Who asked that? I mean, sorry, who said that?
That was me.
A supernode is between unknown node voltages. That's grounded, so that would be 0 volts. That's known, isn't it?
Mhm.
Whoever, all right. So what do I have here? That's 12 volts, right? I don't know this voltage, that would be V1, and I don't know this voltage, V2. Do you all see that, class?
Yeah.
Right? So if I don't know that voltage and that voltage, V1 and V2, now can you see how I could quickly assign currents then once I assign the unknown voltages, right?
Yeah.
I could say this, I'm going to ask some questions just based on your response. I'll know if you get it or not. What's the current here that I've just drawn that arrow through the 6K? Anyone?
V1 over 6 ohms.
How many agree with that? Right, you're right. All right. Now, whoever answered that, don't answer the next one. What's the current through this 12K right there? Anyone? But not the guy who answered.
12 minus V2 over 12 k ohms.
How many see that? Guys, how many see it? Just pop or thumbs up. However you want to affirm. I'm just looking for an affirmation. Does anybody not see this? I don't know who asked the question, but do you see this? Whoever asked the question to start me off? Okay, I'm assuming you do. This is not difficult, but I was asked to do this and I'm trying to respond in the best way that I can figure out how to do. All right, last question, all right? I'll label this one I2, all right? I'm just labeling it I2. I'm gonna label this through the 6K I1, all right? Are you with me? Can you all see what I've done here? Got I1 there and I2 here. All right, now what is the equation for the currents entering and leaving this node 2 where I have my pen? What is it, class?
6 milliamps plus I2 equals I1.
Yes, and how many see that? And give me an affirmation. I mean, I'm asking this so I know, because if you don't know, it's time for me to address it. And I can, from what I'm seeing, I got about 100% affirmation here. If you don't see it, let me know. And I'll try to address it. It should be very obvious at this point. There should be no uncertainty, right? The only uncertainty, well, why do I put V1 on this side? No reason. You can call it VA, you can call it V2, as long as it's not the same as over here. That's the idea. You can call this V1, V2, could call VA, VB, could call this VZ, VY. It doesn't matter as long as they're unique. Got it? And all the voltages are with respect to ground. Everybody good with that?
I have a quick question. Well, it's not about, so some of these node analysis, there's some voltage sources in. So for example, instead of the 6 milliamp current source, there's a volt source right there going from negative to positive.
Then what would that be? Anyone?
So that was my question. Would it be
Supernode?
Say it, someone?
A supernode?
Yes, and a supernode requires what? That you grab both of those nodes and circle them and say everything going into it current-wise is equal to everything going out. Do y'all remember that?
Yes.
Good, I'm glad. And listen, I know I tried to get to all your questions. There are limits on time. I cannot spend 5 hours answering questions on a Sunday evening, but I tried to respond to as many as possible. I hope your GroupMe helps or whatever you're using other ways, because social interacting and really I'm going to level with you on this one. Most of the time, the same question is asked by 5 to 10 people. Most of the time, a single good answer will resolve that on something like GroupMe or Facebook. I'm not real familiar with GroupMe. I've used Facebook for years and years, and the kids generally are pretty good about that. But I think GroupMe is now the new hot ticket, so go use it. Just be aware that everything you do on social media, whether you know it or not, is permanently recorded and accessible to everybody, including law enforcement and university staff. Just remember that. Okay, because I'm tired of getting all these emails explaining people's behavior that I don't know about. Okay, now that in mind, next thing I'm going to ask you is any last questions before the quiz?
I have a quick question. How did you know I2 was going down and not up on that last problem?
This one? Right
Yeah.
here? Oh,
Yeah.
right here? Sorry, right here, pardon me. Right,
Yeah.
right? I arbitrarily assigned it that way. If I would have put it the other way, then it would have been V2 minus 12 over 12K.
Okay.
It's a fair question, though. I mean, if you always go from top to bottom, right to left, I do as a general rule because I try to be consistent, but the current can go either direction. Are we good on that, class? Now, one last thing before we take the quiz, make sure you have either white or yellow paper like this, not red or I guess you could use crosshatch. Do not use a pencil, use a dark pen, black, one of these felt tip markers or blue, or a dark pen. Don't use a pencil. Make sure when you take pictures, they're very visible, right? That what you've done is very visible. Be very neat. You can use more than one sheet of paper to do a problem, but label it problem 1-1, 1-2. You're going to get this in a second. Put all your answers on the upper right corner of the page for the problem, and make sure that each problem is uniquely numbered. Are we good on that? Now, I'm going to give you a full half an hour, more in some cases. I want you to work individually. You have to have your cameras on at all times. And they have to be, it has to be viewable. Now this class is monitored. I don't know how many eyes on it right now. You have to have your cameras on. They have to be able to see you. If you don't, you're in trouble. So turn your cameras on now before I send this out. And don't worry about bandwidth. Just turn all your cameras on. Okay, I got some chat items. We're going to start it in a few minutes. The quiz is about to happen. Whoever asked that question. Turn on your cameras. I'm going to make sure everybody's on.
So does the camera need to be on your face or on your paper?
It has to be on you, your face and body. And hopefully they can infer what it's looking at from there. And I don't know who's recording this, but I know I got more problems with this class than I've had with any other. So let's see, Jacob Lawrence, you have to turn it on. And Gonzalia Zhang, whatever, you have to turn it on. Your cameras, please. Okay, and it needs your picture, not a rodent.
About just the actual submission, like the file?
It's going to go on Canvas. It's going to go on Canvas. It'll be in the assignments section of Canvas.
Does it matter the file type? Does it need to
be? Yeah,
in
it's going to be in a Word format. You'll get that in the quiz. You'll be placing all your pictures in a Word document and uploading it. Okay?
Yes, sir. Thank you.
Now, Thomas Benda, could you please turn your camera on? I mean, with your face, please. I can't send this thing out until I get everything.
Yeah, I'm currently using my laptop and my desktop at the same time. I started the Zoom call on my desktop, and then I remembered I'll just turn off my desktop Zoom because
whatever it takes to.
I'm logged in twice. Here, I'll give it a go.
I mean, is your face up there somewhere?
Yes,
okay,
it is on my laptop.
That's all I need. That's all I need. All right, give me 1 second. And hold on. Okay, fire one. Chapter 2. And the quizzes should be arriving momentarily. Tell me when you get them. If you get them, raise your hand.
Where are they arriving?
Through email. Check your email. Got it? You got it. You got it. You got it. You got it. Got it. Got it. Got it. Okay. Good. It's in a PDF format. Go ahead and start. One last thing I'll say, the quiz is designed for about 15 minutes. It's a straightforward quiz, and if you know what you're doing, you should fly through it. But if you're going to take longer, don't worry. I'm giving you more time, full half hour. Joseph Sanders, can you hear me? Okay, there you are. Never mind. You were off the screen. It's okay. Stay there. Brantley Anderson, your video's not on. I've been notified. Oh, yeah, please keep it on. Peter Lee, can you hear me? I have a monitor that said that you're talking to someone.
I'm talking to myself. Sorry.
Well, don't talk to yourself anymore because the monitor noticed it and it's ready to put a mark against you. So make sure you don't say anything more.
Okay, sorry.
When you're finished, make sure to take pictures and upload everything to a Word file. Make sure it's clear and visible. Apparently, quite a few people have already done that. Louis, Miller, could you please move in the camera so we can see you? Thank you.
Plus, once you're done, you upload it to Canvas and then leave the Zoom call. I checked the Q&A response to it, so you didn't. Okay. Can y'all hear me on this?
Could you repeat that? I didn't. Your mic kind of cut.
I'm sorry. After you're done, please go ahead and submit it to Canvas before you leave the Zoom call. I'm making sure that the name before you leave is associated with the Canvas document.
Are you having office hours after this?
Not today because once the quiz is over, I have to go over the quiz with the grader, but I will on Wednesday.
If I just realized that I put my questions like out of order, would you rather me go back in and resubmit it in order late or just leave it?
No, just leave it the way it was. As long as they're numbered right, it's fine.
Okay, thank you.
Professor, you said you wanted us to box our answers in the top left corner, or
Say that again?
you said you wanted us to box our final answers
Yep.
in the top left,
Upper right hand corner,
upper right. Okay, thank you.
just up in the top.
I just submitted. It says late. Dr. Baginski.
Yeah, it was quarter after was the deadline. You'll get some grace, don't worry.
Okay, it's after 2:30, so all the students in the class that do not get extra time should be finished by now. There are those that get extra time, and you may continue. But this should have been over about quarter after to 20 after. You're getting a lot of allowing certain things. But if you get extra time, go ahead and use it. Those that don't need to get it in as soon as possible if you want to get any credit at all.
Hey, sir. Can I know how much time left? Sir?
Well, you're basically out of time unless you get extra time. Can you get it in as soon as possible?
Yes, I'm uploading the picture. 1 minute.
Is it okay if we go out of the side of our camera to like scan these real quick on the printer?
Yes.
I'm having trouble getting it to a Word document. Do you know what I should do to get there? Any suggestions?
Well, frankly, are you on a Mac or an?
I'm on a Mac. I submitted it as a PDF, but I'm trying to figure out how to.
I tell you what, Mac are not something I know a lot about, but
Okay.
you put it's in Canvas as a PDF.
Yes, I was going to convert it and resubmit it, but I can't figure out how to convert it.
You just take the Word document, insert it in, PDF document, insert it into a Word, and it should do it.
Okay, I'll just do that. Okay,
Just,
thank you.
sure, but you're done. If it's a PDF, it's fine. For now. And at 2:45, everybody should be done because that's 2 times the normal time.
Okay.
Did you say to check with you to make sure you got our file before we leave?
No, go ahead. Did you upload the Canvas?
I did.
Then you're fine to go. Okay. Zachary, are you having trouble uploading it or something? I can't hear you. Unmute yourself. Go ahead.
I just uploaded it. I have double time with my accommodations. So you said before 2:45, right?
Yeah, you're fine. You're fine. I'm just making sure. All right, bye-bye. Matt, are you having any trouble uploading? Say, I can't hear you. You're on mute.
I'm about to upload it right now. I was getting my PDFs into the Word.
Okay.
1 second.
Just insert it in a Word document. Okay.
Okay.
All right. Just is it uploaded?
1 second.
You have it in front of you?
All right, it should be there.
You did upload it?
I uploaded it.
Okay. All right. That's all you need. You can take care, and we'll talk to you on Wednesday. Okay.
All right, thank you. Talk to you.
Bye-bye. All right. Let me go back to my video. All right. What I'm going to do, I tell you what. I don't know who else can get in on this call. I'm going to send you a Zoom link. All right.
Okay.
Sean, that way we'll have a private. I'm just going to shut this whole thing down.